Hey everybody, welcome to the first video of the third unit. This unit is going to be on designing studies. How do we collect data? This video corresponds to section 4.1 in your textbook. So we skipped chapter 3 and we've gone right to chapter 4. So let's talk about an example here. If you want to pause and read this, you can, but basically so pause. This is discussing a poll from 2013 leading up to the election of the governor of Virginia. And the poll said that basically that Republican Ken Cuccinelli and Democrat Terry McAuliffe were in a dead heat at the time. And that's what the poll claims. As we now know, we now have Governor McAuliffe, so he won. But what's interesting is they said that this is a dead heat. And you would say, well, 35 over 32. But what they talk about is that they had a margin of error of 3 percentage points. And that they got that because they called 874 likely voters. And then down here it even goes into more detail of how they conducted the poll. Between September 9th and September 15th, 2013, they called 874 people. They included both landlines and cell phones, and unlisted numbers all had a chance of inclusion. And they said that cell phones completed 37% of the completed interviews. And this is going to get into what we do. How do we create that list? How do we pick people off that list? How do we say the 3%? This will come later in the year. This is going to come later, but for now we're going to talk about how we set up our polls. So the population is the entire group about which we're trying to infer population. So remember that we talked about mu being the population mean, and sigma is the population standard deviation. But in real life, we rarely ever get this information. Instead, what we're going to be taking an x bar, and we're going to be taking an x sub x, which is the sample mean, and the sample standard deviation, and we're going to use those to approximate. These are going to be approximations of these. And the question is, how do we make our approximations as accurate as possible? So what we need to do is we need to identify the sample and the population in a group. So the student government at a high school. So let's look at A. A. The student government at a high school surveys 100 of the students at the school to get opinions about a change to their bell schedule. So what is the population? Well, the population is, for A, is all students at the school. Just at that school, because we only selected from that school. We can't make anything about high school students in general, just at that one high school. And the sample is the 100 students surveyed. So for B, the quality control manager at a bottling company selects a sample of 10 soda cans from a production line every hour to see whether the volume of soda in the cans is an acceptable limit. So the population, is the population all soda cans made every day? No, the population is soda cans made that hour. The sample is the 10 cans selected. So it's going to be very important later on when we start to make inference from our samples, when we start to make predictions, that we understand who the sample is and what's the population we're drawing from. We need to make sure that we can only make inference about the population. And so we have to look at who the population is and design our sample so that it represents our population correctly. So if you want to, you must say exactly what you want to measure. You must give exact definition of your variables. Right? We can't just say soda's made. We have to say soda's made that hour. Really, we should say soda's made that hour at the bottling company. Not at any other places, but at that bottling company. So when we define our variables, we need to be absurdly specific so that, at least for what you're used to, we're actually being the correct level of specific, but it's for you, it's going to feel like you're going above and beyond. And welcome to AP Statistics. So most people don't know how to create a sample. And this is, if you don't select people randomly, you just get a big mess. And so if you just choose the individuals that are easiest, you're going to get really bad data. It's not going to be representative of the population. And the classic example of this is voluntary response sample. And that will lead to bias. So voluntary response sample is if we stop people in the mall at random and asked them, or just said, can we answer a few questions about the upcoming election? Most people would wave us off. The only people that we would get answers to, if we told them that we were going to ask them about the election ahead of time, were people who really cared about the election. And that may not be representative of the people actually voting, because that's what we're trying to predict. If you're taking a poll, you don't care what the people you're talking to think. What you're trying to do is you're trying to estimate what people who actually vote are going to vote on election day. And an example of bias would be is if Fox News and MSNBC ran the exact same poll and they flashed it up on the screen, they told their viewers, what do you think about position X in the government? They would get vastly different results because the people who watch Fox News tend to be conservative and the people who watch MSNBC tend to be liberal. Neither one of those polls would tell us anything about the population in general. It would only tell us about the people who watch Fox News or watch MSNBC News who wanted to respond to the survey. So one of the key things that we're going to see is that you are going to have to randomly select people for your survey. They have to be chosen at random from the population you're trying to describe. And there's many different ways we're going to discuss on how to pick randoms, but basically it's the equivalent of if we put everybody's name in the hat and then we shuffled the hat. You have to shuffle the hat, put all the names in the hat, shuffle them, and then pull a few names out. A simple random sample is where we have an n number of individuals selected randomly from the population. The key, and we will use the acronym SRS. And this is an accepted acronym on the AP exam. So if you write SRS, they know you mean simple random sample. And the key to a simple random sample is that everybody in the population has to have the exact same chance of being selected. There's two ways to choose a random sample that we're going to use in this class. You can obviously draw names out of a hat or flip a coin or do some other stuff, but you got to be careful flipping a coin because the key to a single random sample is that every single person has the same choice of being selected. There's a random digits table in the back of your book that can be used to generate random numbers. If you want, you can read page 213 in your book and it'll explain to you how to do that. Most of the time, we are going to use this command on our calculator, and we'll let the calculator choose a random number for you. Remember, if you're in class and we're going to do anything involving randoms, you have to seed your calculator in advance if you're using one of my calculators, because my Algebra 2 students reset them all the time because they turn them on and there's a normal probability plot or a box and whisker plot, and they freak out because their graph of the parabola is not there. So they reset it, and when you reset it, the seed number goes back to 0. So remember, our general thing that we're going to do for our seed numbers, we're going to type in the last 5 digits of our cell phone. We'll hit store, and then we go to math and hit rand. If you need to do that anytime you're going to be doing a random command in this class. That way we get accurate results. Now, sometimes we can't simply take a simple random sample. Sometimes we have to do more. Sometimes we want to do something easier. And so 2 alternatives to a simple random sample where we just pick one person, a certain number of people at random from the population. The first one is what's known as a stratified random sample. Stratified random sample is where we know that different people in the population behave differently. And so we want to make sure that we get a certain percentage of that. It goes back to what we were discussing earlier here. Is if we go back to this was a stratified sample because they made sure they had a certain number of cell phones. And they made sure they had a certain number of residential telephone numbers. And the reason for that is that it would skew the results if they didn't. Because younger people are more likely to have a cell phone, but younger people are more likely to vote Democrat. Older people are more likely to have a landline, but older people are more likely to vote Republican. And so they knew there was a confounding variable in there. They knew that there was something that they needed to control for. So that's when you do a stratified sample, is you divide your population up into different similar groups or strata. And then you take an SRS from each of the strata and then combine them to form the full sample. And we're going to play with this in class, the next 2 classes. So right now I just want you to know this definition. And the reason you do it is control for what it confounding variables. Well, that leads the question, Mr. Thailander, what is a confounding variable? A confounding variable is an extraneous variable that correlates positively or negatively with both the dependent variable and the independent variable. Huh? So let's consider Social Security. If I asked you guys in my class who haven't even turned 18 yet for the most part, or certainly are under 21, excuse the interruption. If I asked you about Social Security and like, would you be in favor of getting Social Security and lessening your taxes? You'd be like, yeah, maybe. But if I asked someone who is 70 or 62, only a few years away from receiving their Social Security payments, and have been paying Social Security tax for the last 40 years of their life, they'd be like, oh, heck no. So if we designed a sample, and just by pure random chance we got all young people, that wouldn't really give us an accurate representation of the population. Or if we randomly selected older people, it wouldn't give us a accurate picture of the population. So what we would do is we would divide our population into strata. And one strata would be younger people. And the other strata would be older people. And we would select randomly from the young, we'd select, say, half of our population from the younger and half of our population from the older, and that would combine to give us a poll. And we're going to do a whole exercise on this, and you're going to see how stratifying works. But we do it when we know there's some other variable that's going to affect the results, and we want to make sure we can control for it. So strata is all about knowing that there might be a problem in our results, and we do something more complicated to compensate for it. So if we stratify our sample, it means more work, but it probably means better results. The other type of sampling we'll do would be a cluster sample. In a cluster sample, we don't do to get better results. We do it because it makes our life a lot easier. Consider if we wanted to take a random survey of sophomores and juniors about school uniforms. So to create a simple random sample, you would have to go to the school registrar, get a list of every single student, select names at random from the list of juniors, and select random names from a list of sophomores, then pull up their bell schedule to find out where they were, go find them and ask them the question. A cluster is saying, hey, things are more or less randomly distributed in the school, so instead of selecting 30 sophomores at random, we're going to select one 10th grade PE class at random and ask everyone in it. And that would give us a sample size of 30. Now, they were still randomly selected, the PE class was, and we're just going to make the assumption that all the PE classes are kind of mixed together. Nobody's has a problem with that. That works great for the sophomores. Now, we can't do that with the juniors because they don't take PE. So then we're going to talk about selecting, say, maybe an English class at random. The problem is that not all 11th grade English classes are the same. There might be an English 11 class for everybody who failed it and is taking it a second time and needs to pass their writing. There's also an AP English class. And those two classes are not the same. So we could do a cluster survey of the sophomores, but we would have a lot of troubles doing a cluster of the juniors. Once again, we're going to play with this more in class. But clusters are not chosen to get better statistical results. They are chosen mainly for practical reasons. Should be reasons to make collecting, wow, there's a couple typos in here, the data for the study easier. The key to this is that strata should all be people who are alike. Young people, old people. Clusters should be all mixed together. There shouldn't be any patterns in the cluster. So since the clusters themselves are random, by picking one of them at random, we keep our randomness. So these are the concepts I need you to have in hand because we're going to spend a lot of time doing samples in the next two classes. And I will see you next class.